Okay girls, homework. So 1 to 6 on the first few pages of the circle, which is on page 420. So we were up on page 420 and we did page 422, 1 to 6. Any problems? 1 to 6, any problems? No, easy peasy lemon squeezy, yeah?
Do you know how, like, for yesterday we were doing the example how you only use like the 0.00. When it's like not the 0.00, and so you're just using like H and K like it is in the book.
Yeah, we're getting onto that.
Okay, sorry, that was what
Yeah, you're ruining the surprise now for everyone. Yeah. So yeah, today, yeah, you're right. No, today there's another formula, right? That when the centre is not HK.
Okay,
right. In fact, it's the same formula, because if you put in H and K as no, you'll end up with x squared plus y squared equals r squared. You know. So yeah, you're just jumping ahead there, Emma. Trying to steal my thunder. Yeah. Okay, I won't hold it against you this time. Right. God, I was busy. Now, right, I'll get out of the way now because I don't need that. Right, okay. So, as Louise said, as Emma said, we have to deal with when the point centre is not naught. Okay, so I'll just where is this? Joined. Right, okay, so all right, okay. Before I get on to when the centre is not 0, we can decide. There's a long way. Don't write this down because this is a long way of doing it, and you will never be doing it the long way, right? Okay. So if you want to decide, when if a point is inside, outside, or on the circle. So we're still dealing with circle, centre, naught. But this also applies to circles with centre naught when we move on to them. Right, okay, so if you're trying to decide, is this point, and they do ask you this question, is this point inside the circle, outside the circle, or on the circle? Right, okay, without me ever telling you anything about a circle, you could figure this out. Right, you could use the distance, the length formula, couldn't you? You get the length, the distance between the centre of the circle and the point you're investigating. And if it's smaller than the radius, it must be inside the circle. If it's equal to the radius, it must be on the circle. And if it's bigger, the length of the line is bigger than the radius, it must be outside the circle. So you could answer this sum without me ever teaching you anything about a circle. Okay? But there's a shortcut. Thank God. We don't like the distance formula, it takes too long. Right, okay? Is that alright? Okay, so old school, right? Doing research, know nothing about circles. If I said, is this point inside, outside, or on the circle, you get the distance between the centre and the point and compare it to the radius. If it's smaller than the radius, it's inside the circle. If it's the same size as the radius, it's on the circle. And if it's larger than the radius, it's outside the circle. Are we okay with that? Okay, but that's method 1, which is what I just said. Method 2, right, substitute the coordinates of the point into the given equation. So do you want to just write down the heading, points and circles, right, and maybe the first sentence there, a given point may be inside, outside, or on the circle. And then we'll just go skip to method 2 because it's way handier, shorter, easier. less mundane, whatever you want to say. Right, so just write down the heading and the first sentence. A given point, maybe inside, outside, or on the circle. Inside, on, or outside the circle. Ready for me? Yeah? So we're going to skip on to method 2 because method 1 takes too long. Substitute the coordinates of the point into the given equation of the circle. Right, okay. So substitute in. Right. And if the left side ends up being less than the right side, it's inside the circle. If the left side ends up being equal to the right side, it's on the circle. And if the left side ends up being greater than the right side, it's outside the circle. Okay? So way shorter, no distance formula, etc. They don't go into this until kind of well into the chapter, which is well to do it now. And this works for the next formula I'm going to give you, so it works for the next one as well. Okay, are we good to go? Right, okay, so, right, question, investigate, example, investigate whether the point 32 is inside, on, or outside the circle. X squared plus y squared equals 10. Right, okay. Take longer to write down than it will to do, but anyway. Right, okay, so this is, all you have to do is everywhere you see an x, put in a 3. So this is 3 squared plus 2 in for y, 2 squared, and you're comparing it to 10. Okay, so 3 squared is 9, 2 squared is 4, that's 13. So 13 is actually greater than 10. Okay, so what does that mean? Outside the circle. Couldn't be easier, yeah? Okay, happy with that. That's why we were just doing one example of that, and we're moving on, because that's how easy it is. Is that alright? Can move, go, yeah, fine, we all good? Right, equations of the circle now. Circle centre HK, right? As in, we're no longer, now we're moving on to circles that can be anywhere on the coordinate diagram. And we call their centres, we call the centre H and K, right? So if they tell you the centre, it's H and K. Now look, please note, it's X minus H and Y minus K. So if you're reading your your centre from the formula, you have to change the sign of the H and K to get the centre. Okay? As in, it's fine filling out the formula, but you know, when you're given the formula looking for the centre, you have to change the signs of H and K. Is that alright? In the log tables, right? And I said the x squared plus y squared equals r squared is not in the log tables, but look, if you put in naught for HK, you'll end up with x squared plus y squared equals r squared, wouldn't you? Right, okay, so it kind of is in the log tables. But that's in the log tables. Right, okay, so you don't even have to remember it. Is that alright? Moving swiftly on. Yeah? No? Not yet? Okay.
So HK is just like any random coordinate?
Well, it's not, it's the centre of the circle that they tell you in the question.
Oh.
Yeah. Okay. So it's the centre of the circle. So they'll either give you the equation, they'll give you the centre and the radius and ask for the equation, or give you the equation and ask for the centre and the radius. Okay? Right? Are we good now? Okay, that's a yes. Right. Find the equation of the circle with centre minus 2 minus 3 and radius 4. So it's x minus hb squared plus y minus kt squared equals r squared. So we call the centre h and k and the radius is 4. Okay, so it's x minus 2 all to be squared plus y minus 3 all to be squared equals 4 to be squared. So that becomes a plus, and you get x minus 2 to be squared plus y minus plus 3 to be squared equals 16. And you wouldn't multiply out unless they ask you to multiply it out. Okay? And they might ask, they would never ask a normal level student to multiply it out, but they might ask a higher level student because there's other forms that you need to know about. Right? Okay, harder formulas. Is that alright? Happy with that? Moving swiftly on? No, not yet. Not so swiftly. Right, okay, we good? Right, example 2, here's the equation, find the centre of the radius. So it's always the opposite sign to what's in the bracket. So the centre is minus 3, 4, okay, because that's minus h and minus k. So, and the centre is hk. So minus 3, 4, and the radius would be the square root of 8. And if you want to write that as 2 root 2, you can, but square root of 8 is fine. Right, so 3, 4, opposite sign, okay, because it's minus h and minus k in the formula. I didn't do the whole, sure didn't, did I? No, I didn't, because I didn't know how it's absent. I just do it on my phone. Right, Vivian, Diane, Sahira, you're all here, Emma's here, Hope is here, Lucy's here, Ashton's out. Basma's out. Alright. Louise here. Louise is out. Joan is here. Alba. Kira. Bo. Alfie. NG. And Kira. Here. Right. Okay. Okay. I forgot to do it yesterday as well. Right, okay, next one. Right, I'm going to leave you do this yourselves. Right, so you can do it in your homework copy or you can write it in as an example if you're confident you're going to get it right. You should be confident you're going to get it right, please. So they're giving you the end points of the diameter of the circle, how to get the centre, end points for diameter, how to get the midpoint, yeah, wouldn't you? How would you get the radius, the length of the radius? You'd use the distance formula, wouldn't you? And then the equation of the circle, you'd use x minus h plus 1 minus k squared equals r squared. Okay? So midpoint formula, length formula, and x minus h v squared. Do you want the midpoint formula and all that? Or can you remember it?
So the length of the radius would be like half the full length?
You could use those 2 points and have your answer,
Yeah.
or you could use your centre and one of those points, and then you wouldn't have to have your answer.
Okay.
Okay, it's up to you. You should get the same thing. Will I put up the formulas?
Yes.
You ready? Everyone ready? There they are, written alongside each other, underneath each other.
The screen is still on the.
I'll never get it right. Look at that now. Lovely. Lovely. Now it's blurry. I see if we can manage that now. Distance formula, midpoint formula. Okay. I don't just have the labels written beside them. Okay. Sorry. Sorry. Right, girls, did we get an answer? Two, which is one. Midpoint, 1, 3. 1, 3 for the midpoint? Right. Length of the radius, 1, 3 to that, so it'd be 1, that'd be 2 squared. Square root of 8. Do you get that? For the radius? Square root of 8. Right, okay. And then you fill it into x minus h squared, so it's x minus 1 to be squared plus y minus 3 to be squared equals root 8 to be squared, which is just 8. Agree? Agree? Or did I make a mistake? I did all this in my head in 2 seconds, so have I a mistake? No? That's okay. Right. Everyone okay? Any questions? Anyone run into bother anywhere? Right. Okay. So I'm going to, you needn't write down the next bit now for a minute. Right, okay. Right. So if I take the that equation, right, that we just got there, right, okay, it's, oh, it's on freeze. Right. Okay, and it's on right, if I just take that equation I got there, it was x minus 1 to be squared, right, okay, plus y minus 2 to be squared, right, equals, what did I get, 8. Okay, right, don't bother writing this down now for a minute, because I have notes on this in a minute, but this is just broke the table, broke myself. Right, if I was to square this out, square the first term, twice the first by the second, square the last. Don't ask me where the minus 2x came from, a puppy will die. Right, square the first term, y squared, twice the first by the second, minus 4y, plus 4, and I'm going to bring over the 8, right, equals 0. Right, so I'm going to put the x squared term first. Right, then I'm going to put the y squared term, then I'm going to put the x term minus 2x, then I'm going to put the y term minus 4y, right, and then I'm going to put the numbers, that's a 0, sorry, over there it looks like a 6, 1 and 4 is 5, take away 8 is minus 3, yeah? Okay, is that alright? Are we okay with that? Okay, that's a different way of writing the equation of the same circle, would you agree? This is called the general equation, right, okay? So this is called the general equation of a circle, right, okay? So sometimes it's not written like this, sometimes it's written like this, okay? If they said find the equation of a circle, and they didn't tell you which form to put it in, you can give it in either, okay? Right, sometimes they'll ask you to give it like this, sometimes they'll ask you to give it like this, okay? Right, now, if we didn't know the centre and radius, now we do know the centre and radius, right, would we be able to come up with where, you probably won't, but just would you be able to come up with how would you get the centre and radius from this? How would you get the centre? Right, the centre is what, 1, 2? 1, 2 is the centre? Isn't it? Listen, I wrote down the wrong one. Yeah, I wrote down the wrong number. It's grand. Centre of that circle would be 1, 2, wouldn't it? Right. Anyone see where would you get 1, 2 here? In front of the x term, if you have it and change the sign. Agreed? You get 1, wouldn't you? In front of the y, if you have it and change the sign, you get 2. Right, okay? Right. So you're never going to come up with where they get the radius from that. But that's okay because it's in the log tables. So do you want to write this down? The general, I don't have a PowerPoint on this. The general equation of a circle, right, okay, the line is on the screen not on my writing. Okay, so the good news is, right, it's in the log tables, right? Okay, something that always confused me is F comes before G in the alphabet, agreed? But in the general equation of a circle, G becomes before F. I don't know why. Right, I want to ask the person who came up with this. Right, why not F before G? So remember it's backwards. G is first. Right, remember it's backwards. G is first. G is with the X, F is with the Y. Okay, so G is with the X, F is with the Y. Right, and the centre is minus G minus F. So it's backwards. It's not FG, it's GF. Right, okay, and these are in the log tables, right, on page 19, the page over from the line. There's the general equation there that we had, and this is all down here. Look, minus G minus F, there it is there, minus G minus F and the radius, okay? We'll get to this, okay? Right, is that alright? Okay? So it's called the general equation of a circle. It's basically the other equation multiplied out. Okay? And they write it x squared term, then y squared term, then x term, then y term, then c, the number. Right? Okay? And it's 2g is in front here and 2f is in front here, and the centre you need to change the sign. So you have to have the coefficient of x and change the sign. Have the coefficient of y and change the sign. Right, okay, so we'll just do example 1 here. You all ready for me? Yeah, okay. So what I would do is 2g, what's 2g equal to? 2g is equal to what? The number in front of x. What's the number in front of x? Minus 8. So that means g is equal to minus 4. Agreed? 2f is equal to the number in front of y. So what's 2f equal to? 10, so that means f is equal to 5. Right, then the centre is minus g minus f. So it's the opposite signs to what you just got. So what's the centre? 4 minus 5. Lovely. And then the radius, you just fill in the formula, square root of g squared plus f squared minus c, so it's the square root of, and look, you've g up here, you're not changing signs here, it's minus 4 squared plus 5 to be squared, and then minus c is the number in the equation, so it's minus 8. Is that alright? Okay, so that's 16 plus 25, which is 41, take away 8 is 33. It's weird because I made it up. Okay, is that alright?
Excuse me please, a reminder that French Club will take place in room 9 today for all 6th years at lunchtime, and a purple coloured red balloon card was lost yesterday in school. The surname on it is Grew, G-R-E-W. If anyone finds it, please bring it to reception. Also there's a black framed pair of glasses in reception. They were found handed in yesterday. Just a reminder about the shoebox appeal. We're asking Royal students to make a Christmas shoebox for this year's shoebox appeal. Shoeboxes can be dropped in the front parlour by tomorrow, Thursday. And please bring in a separate envelope of €4 along with your shoebox to cover shipping costs. If anyone wants an leaflet, they can be collected from outside the staff room. Thank you.
Okay, so section 11.2, which is on page 425, do the odd numbers. Okay. And that's loads, so, sorry, but we have to motor.